So the mission might be to knock this guy into the lava and then go get the totem and drag it back into the rock area and see if that works. Forwards, right, drags him into the lava. Oh yeah, now we're talking. Woohoo! So let me show you how I made the board. I've made a lot of 9cm by 9cm squares. I wanted to make 10cm squares on the board, so I've decided that if I make 9cm by 9cm, it allows me to get a bit of room in between to attach some tape to the board and separate them nicely. So the first thing I did was to make and laminate a whole bunch of squares. For this particular board, it was 6 by 9 squares, so I needed to do 54 tiles. And I just found some random pixelated squares on the internet, which I laminated and then cut up. It took a long time to make all 54 squares. And then what I did, I got a piece of core flute, which was 600mm by 900mm, and I divided it up into 10cm squares. So I just marked by every 100mm, I put a mark down, and basically ended up with a whole bunch of lines which I joined up from both sides using my big long spirit level, and that allowed me to do very straight lines and parallel lines, and I ended up with a 9 by 6 grid of 10cm squares. And then I could put the pictures down just randomly where I thought they might look good. I decided that I was going to have some starting points in each corner. For 3 of the corners I was going to have lava, grass and stone. So I put them all out in the positions where I wanted, shuffle them around a little bit, and then I had to sticky tape them all down. So I used some tape and very carefully put them all in the middle of every square. And because they were 9cm by 9cm and the squares were 1cm bigger, there was about half a centimetre around the edge of each square. So after I stuck them all down with tape, I got some electrical tape out, put that around the outside of the edge of the board, and it helped hold all the ones on the outside in position. Then I got some parallel lines happening with the electrical tape, and that perfectly aligned them all and stuck them down nicely, so they had a tiny bit of each square under each piece of tape, and it ended up looking quite beautiful. I actually did this 4 times. I ended up with 4 boards, so I had to make some targets or things for the robot to collect. So I laminated some pictures of totems and creepers and pickaxes and things, and I laminated those and stuck them on each block with some blue tack. So I ended up with a couple of diamonds for each kit, an enchanted golden apple for each kit, and the blue tack just held the pieces on nicely. But there's a lot of mucking around, of course, but it was worth it because it was pretty cool in the end. So I just I cut out things like 4 pieces, 4 totem drawings, and stuck one on each side of a cube that I made out of blocks. Not quite a cube, but close enough. And then I ended up with a beautiful totem that had a picture on each side. Spent a lot of time making these videos, so I'd really appreciate it if you could press the like button. Thanks for helping me out. So once I'd done a couple of diamonds, I was going to put 2 diamonds on each board, and I was going to put the apple on the picture of the apple, and the totem on the picture of the totem, and the pickaxe on the picture of the pickaxe, and then randomly just place the creepers wherever I wanted. The goal will always be to try and knock the creepers into the lava. So this is the way I built the little car that pushes things around. Started with the hub, placed 3 pins on each side to hold the motors in, and it worked out that once the motors were in, the end of the motor was kind of at the same end that the button to turn the hub on was. So put that down that end like that, so you got the wheels turning near the on-off button. Then you put the other one on parallel, and it's looking pretty good. Then I had to add the ball and socket, so I use these grey joiners a lot, which I love, and put that in there, and then that allows you to add the ball and socket very easily, and when the wheels are on, it is quite level to the ground. There's lots of ways you can stick the wheels on, but I just use a couple of black pins, put the wheels on. I use little wheels because if you use little wheels, then the calculations in centimeters are a lot more accurate. I mean, you can always use a block to tell the hub that you're using bigger wheels, but I just like to use little wheels because a little car in this sort of thing, I think, is a lot more accurate than the big one. Then I just stuck this beam across the top, just above the Bluetooth button, because that's where we're going to stick our motor with the claw thing that's going to grab things. I always tangle my wires up so they don't get into the wheels. I don't use those little clips anymore because I've found out they damage my motors. Then we're going to build this contraption or attachment that's going to scoop up the things. So you put a little axle in there, put a cog in there, a tiny cog, the smallest one you can find. Then we'll stick a little black square on top of that. Black frame, not a square, it's a rectangle, isn't it? Put the rectangle on top. And then you've got to build the contraption, and these are the parts that I used. So once I found all the parts, I put 4 little pins, blue pins in the spots there, and an axle holding in a cog. And then you can put these yellow arms on the outside because the yellow arms have got cross holes in them, so you can use the cross holes on the cross axles, and that will allow it to be strong and lift things up and not just rotate around. So stick the cross holes over the cross axle, then you'll see that it can sort of manually go up and down. Then we're going to attach this whole thing onto the black frame that we put on the motor, so it kind of goes to the side a little bit, but the cog lines up really nicely, and then that'll work really well once it's connected. I'm going to use a special piece that I made that connects them, holds these things in place. The idea is that, I mean, you could secure it better with little pins and stuff, but I like to be able to change my weapons over or my attachments over. So I made this thing out of 2 biscuits and 2 longer blue pins, and then that will hold the 2 black frames together nicely as they just sit in there. It holds it together and keeps the cogs together and helps it work better. I mean, there's lots of ways you could do this, but that's what I like to do, because then you can add lots of other attachments as well if you really want to. And just sits on top. It's a little bit off balance. I mean, I could have made it a lot stronger, but I didn't want to complicate the robot too much. You could put some beams down the side to make it a bit stronger, hold it on a bit better. Make sure you plug in the motor into port B. So we're going to plug the motor that moves the attachment into port B, and the movement motors that move the wheels go into ports C and D for my robot, for my coding. And every time I attempt the challenge, I just make sure that red crossbar is above the axle like that, so it's in this sort of position at the very start every time I attempt the challenge. So for every challenge I made a set of cards. You can see that there's 12 different cards here that I printed and laminated as well, and every card it asks you to start in a particular corner, either grass or lava or stone. So this particular card asks you to start in the grass corner, and then it says to knock over 2 creepers into the lava, and then it says to go retrieve the totem and drag it back into the grassed area. So that's the challenge for this one, and let's see if it works. Put on the starting point. It's always good to start in exactly the same point. Here's the code that I used. It's going to go forward, knock down the creeper, knock down the other creeper, the arm's going to go up, and then it's going to drive towards the totem and drag it into the grass. Does a bit of a spin here for fanciness, and the totem's in the grass. So whenever you're coding a vehicle to move, you need to make sure that you set the movement motors. In other words, you're telling the hub where you've plugged the motors in that move the robot. My motors are plugged into C and D, so I'm going to tell it that I've plugged them into C and D. Then you've got to set a speed. Now for this sort of activity, it's good to have a fairly slow speed. 30% is good. That's what I use for this activity. And then for my robots, this is the arm. This is the arm that comes down to collect things. And for this particular robot, if I start the arm in an upright position, when it does 0.7 rotation, it pretty much goes down to the ground. It's a little bit confusing because you might think it would be 0.5 rotation, but because we're using cogs and they're different sizes, then it mucks up the actual rotations here. So for this particular robot, 0.7 is about half of a turn on my robot. So that's what I used every time I want the arm to go up or down. Remember, always start in upright position. And then I just moved the number of centimeters. So the last example I showed you, I moved forward 20 centimeters at the start. And then every time I wanted to do a turn with this robot, I worked out that a right turn of 100 for 0.37 of rotation, that would make this particular robot turn at a right angle. Your robot could be different if you build it differently, but if you copied my instructions, then this is about a right angle if you use small wheels. Okay, right 100 is important to do that. Don't do these sorts of turns because they're very wide turns, but a right 100% turn, that's kind of spinning on the spot. So that's what you want to do if you want to turn sharp right angles. Always go right 100 or left -100. So I would just go forwards and backwards. Because all the squares were 10 centimeters and I use small wheels, it was pretty easy to judge. And then I might go right again, and I might sometimes go forward 20 and then go backwards, or turn left this time. Again, for left, 0.37 of a turn was a left right angle for this particular robot. Then the arm could go back up again, and so forth and so on, till you've got something that looks like this. So that was the type of code I used. Once you work out how far your arm needs to go up and down, and what a right angle or left right angle is, a right angle or a left right angle, then you could keep using the same values every time you wanted to do that sort of turn. The last one, I wanted to do about a 180 degree turn, so I've made this double basically to 0.75. And for the second card here, I'll just show you two cards. This one you've got to click both diamonds and also knock both the creepers into the lava and drag the diamonds back into the rock area. So here we go. It's going to go get one diamond, then it's going to lift up and go get the other diamond. And then it's going to knock the two creepers into the lava. Yes! And then it's going to take the diamonds back to the rock area. Woohoo! If you enjoy my videos, why not give me a small donation by pressing the thanks button at the bottom of every video. You can tap thanks and give me a donation, or you could even become a member by joining my channel and become an official Robot Man fan, just like these guys. I've also got some videos that you might like to see, some other lessons, and a playlist of all my Spike Prime tricks. Check them out.